Hello student, welcome to my channel Learn Physics. Today I will be discussing the acceleration due to gravity from ncert class 9. This video will be extremely helpful for you. Please like, share and comment on this. Now let's start. First of all, acceleration due to gravity. When a body is falling under gravity, the acceleration produced on the body. This acceleration is known as acceleration due to gravity. Its symbol is small g. Now we have to derive the expression of small g in terms of mass of the earth and radius of the earth. Okay? Suppose a body of mass m is on the earth's surface. So the gravitational force of attraction on m due to mass m, that is the mass of the earth, is F equal to, look at this, g, mass of the earth, mass of the body, divided by square of the distance of separation. Look at this, distance of separation is radius. So this is the r square. Okay. Now the direction of this force is directed towards the center of the earth. Okay, if g be the acceleration due to gravity, then F equal to, this is the mg. Now equating these two relations, this and this, we get, look at this, mg equal to g capital M small m by r square. Look at this and this cancel out, therefore g equal to capital G m by r square. Therefore, acceleration due to gravity directly proportional to mass of the earth and inversely proportional to the square of the radius. Look at this, the equatorial radius RE greater than the polar radius. So, greater the radius, smaller the g. So, g at equator is less than g at pole. Now we have to calculate the acceleration due to gravity on earth's surface. Look at this, g is equal to 6.7 into 10 to the power minus 11 Newton meter square kg to the power minus 2. Mass of the earth, capital M, this is the 6 into 10 to the power 24 kg. And radius of the earth 6.4 into 10 to the power 6 meter. Okay, now if we put this value in this equation, look at this, we get g equal to g means 6.7 into 10 to the power minus 11. Mass of the earth 6 into 10 to the power 24 and radius square, that is 6.4 into 10 to the power 6 whole square. Okay, look at this here, power 24, power minus 11. So power is 13. Okay, and here 10 to the power 12. So 10 to the power 13 by 10 to the power 12, that is the 10. So look at this, this is the 6.7 into 6 divided by 6.4 whole square into 10. Okay, therefore this is the 9.8 meter per second square. Okay, understood? Now a numerical. If earth sinks such that its radius becomes half of present value, find acceleration due to gravity on earth's surface. So look at this, here r becomes r by 2 and mass remains same. So look at this, initially the acceleration due to gravity, g is the, this is the g capital M by r square. This is equation number 1. Okay, now look at this, g dash, here g m and r becomes r by 2. So this is the r by 2 whole square. Look at this, this is the g m by r square by 4. So look at this, this is the 4 into gm by r square. Okay, now this is the 4 into, this is the g. So this becomes, look at this, so g dash becomes 4 into 9.8, that is 39.2 meter per second square. Okay, understood? So acceleration due to gravity on Earth's surface becomes 4 times of its present value, that is 39.2 meter per second square. Okay, understood? Next, now we have to compare the relation between acceleration due to gravity on moon surface and acceleration due to gravity on Earth's surface. Here mass of the Earth is 5.98 in 10 to the power 24 kg and radius 6.37 into 10 to the power 6 meter, and mass of the moon 7.36 into 10 to the power 22 kg and radius 1.74 into 10 to the power 5 into 10 to the power 6 meter. Look at this, we know G equal to, this is the Gm by R square. So look at this, G directly proportional to M and G inversely proportional to square of radius. Here G2 by G1, look at this, this is the M2 by M1, and as this is the inversely proportional, so this is the R1 by R2 whole square. Okay, now put this value, look at this divided by this. So look at this, this is the 7.36 divided by 5.98, this is the 10 to the power 22 and this is the 10 to the power 24. Okay, and R1 R2, look at this by this. So this is the 6.37 divided by 1.74. Look at this by this, look at this and this cancel out, so this whole square. So we get this and this is the 100, so 7.36 by 598 into 6.37 divided by 1.74 whole square. This almost equal to 1 by 6. Therefore, G2 equal to G1 by 6. Therefore, acceleration due to gravity on moon surface is 1/6 of acceleration due to gravity on Earth's surface. Okay, next. Now, exemplar numerical 23. Look at this, a hypothetical case where radius of the Earth is half of its present radius and mass becomes 4 times of its present mass. What will be the acceleration due to gravity? We know the acceleration due to gravity on Earth's surface, this is the Gm by R square. This is the present value. Now look at this, G1, that is G, this is the mass of the Earth and this is the R1 square. Now here M1 is equal to 4M and R1 equal to R by 2. So look at this, this is the G into 4M divided by, this is the R by 2 whole square. So this is the 4 Gm divided by R square by 4. So this is the 16 Gm divided by R square, therefore 16 G. Therefore acceleration due to gravity becomes 16 times of its present value. Now what is the weight? Look at this, this is the 16 times. Weight mg1, so this is the m into 16g, so this is the 16 into weight of the body, so weight also becomes 16 times. Okay, understood? Next, now exemplar 19. 2 packets dropped from 2 aeroplanes, one above the North Pole and other above the equator from the same height. We have to calculate the, now which will the 2 packets take same time to reach the Earth's surface. Look at this, we know acceleration due to gravity is inversely proportional to the square of the radius. The equatorial radius is more than the polar radius. Therefore, acceleration due to gravity at the equator is less than acceleration due to gravity at pole. Look at this, here acceleration more, here acceleration less. So here takes less time to reach the North Pole, and here takes more time to reach the equator. Okay. Now we have to establish the relation between acceleration due to gravity and mean density of Earth. Look at this. This is the Earth of radius capital R. Its mass m. So mass equal to volume into density. Volume is the V, density is the rho. Now as it is a spherical in shape, so volume V equal to 4/3 pi, this is the R cube rho. Now acceleration due to gravity, G equal to, this is the G capital M by R square. Now look at this here, G, M is equal to 4/3 pi R cube rho. So this is the 4/3 pi capital R cube rho divided by R square. Now here R cube and here R square. So this is the 4/3 pi R G rho is the acceleration due to gravity in terms of mean density of Earth. So mean density of Earth rho is equal to, this is the 3G divided by 4 pi R G. Okay, this is the result of the exemplar numerical E21. Okay, understood? Now acceleration due to gravity. Now acceleration due to gravity due to variation of radius of Earth. Now look at this. We know G equal to, this is the Gm by R square. Now look at this, G constant, mass of the Earth also constant. Here radius changes. Now look at this, G is equal to, this is the Gm R to the power minus 2. As this is the constant, so we can write K R to the power minus 2. Now variation of delta G, this is the K, this is the minus 2 delta R divided by R cube. Okay, therefore look at this, delta G by G, this is equal to minus 2K delta R by R cube into K R to the power minus 2. So look at this here, delta G by G, look at this cancel out, and this is the minus 2 delta R by R. Therefore look at this, if radius of Earth decreased by 1%, then acceleration due to gravity is increased by 2% because it is negative sign. If radius decreases, then G increases. Okay. Now a numerical. Now if we use this formula, we can get delta G by G, this is the minus 2 delta R by R. So this is the minus 2 and delta R by R is the minus 2%. So this is the 4%. Therefore acceleration due to gravity is increased by 4%. Okay. Look at this, the acceleration due to gravity at height h from the Earth's surface is G_r square by R plus h whole square. If h is very small, then this formula is converted into G into 1 minus 2h by R. And due to depth, the acceleration due to gravity, look at this, G dash, G into 1 minus x by R. So look at this, at the center, here x equals to R, at the center x equals to R. So at the center of the Earth, acceleration due to gravity 1 minus R by R. So this is the 1 minus 1, so this is the 0. Look at this, if a graph is plotted between acceleration due to gravity and distance from the center, then this graph becomes straight line within the Earth, and outside the Earth it is the curved. Look at this here, G proportionate R, that is distance increases from the center, acceleration due to increases, and it becomes maximum value at the surface, then it again decreases. Look at this here, G proportionate 1 by R square. Okay, and this is the R equal to capital R, radius of the earth. Okay, understood? Next. Now, weight of a body. The weight of a body is the gravitational pull of the body towards the center of the earth is called weight of the body. Now, weight W equal to, this is the M into G. Okay, and mass. Mass is the amount of substance present within the body. Now, what is the difference between mass and weight? Look at this. The mass is the, now what is the difference between mass and weight? Mass is the amount of substance present in a body. Weight is the gravitational pull of an object towards the center of the earth. Look at this. It is a scalar quantity. It is a vector quantity. Mass is always constant. That is, mass of an object same on the earth's surface, same on the Himalaya, and same on the moon. But weight depends on acceleration due to gravity, so weight will be different at different places. Okay, mass is the characteristic property of a substance, but weight is not the characteristic property of a substance. What is the unit of mass? Kg. What is the unit of weight? Newton. Okay, understood? Next. Amit buys few gold from his friend at the pole and he returned to his friend at the equator. He lose or gain. Look at this. Weight is equal to mass into acceleration due to gravity. Suppose weight at the pole is equal to mp and this is the gp. Gp is the acceleration due to gravity at pole. Look at this. The same weight returned at the equator. So mass of the gold at equator me and acceleration due to gravity. This is the mp into gp equal to me into g. So look at this. This is the me by mp. This is equal to gp by g. Look at this. The acceleration due to gravity at pole greater than acceleration due to gravity at equator. So this is greater than 1. Therefore, mass at equator greater than mass at pole. Therefore, Amit loses because he gets less mass but return more mass. Okay, understood? Now look at this. ncert in numerical 12. The acceleration due to gravity on moon surface is 1/6 of acceleration due to gravity on earth surface. Find the weight of 10 kg object at earth surface and on moon surface. Now weight on earth surface, this is the WE, so this is the m into g, so 10 into 9.8, so this is the 98 Newton. Okay, now on moon surface, this is the m into g by 6, so this is the 98 by 6 Newton. This is the 48 by 3, so this is the 16.3 Newton. Okay, understood? Next, look at this. A person lift a 15 kg mass on earth surface. What amount of mass he lifted on moon surface? Look at this. The weight lifted on the earth surface 15 into g. So weight lifted W equal to m into, this is the g by 6. Now W equal to 15g. So this is the 15g into m into g by 6. Therefore m equals to, this is the 90. So on the moon surface he lifted the weight equivalent to the mass 15 kg. Okay, many thanks for watching this video. This video will be extremely helpful for class 9 and foundation of NEET, main and advanced. Please like, share and comment on the video and subscribe my channel to learn physics easily. Okay.